We will be looking at how to solve quadratic inequalities algebraically. We have looked at how to solve them graphically, but this time we'll show how to do them algebraically. We're just going to focus on the steps that are involved in solving quadratic inequalities algebraically, and then we're going to go through some examples. So here are the steps. The first thing you want to do is replace the inequality with an equal to sign. All that means that we're going to change the inequality first to an equation, and then we're going to solve the quadratic equation to get the zeros or the roots of the quadratic equation. We'll plot the zeros on a number line, and then we're going to test a point from each of the regions in an inequality, and we're going to use that to identify the regions that satisfy the inequality, and the regions that we identify will now become the solution set for inequality. So let's put that to practice. So the first thing we're going to do is convert it to an equation. So we have x squared minus 9x plus 8 equal to 0. So now we're going to solve this equation, quadratic equation. So we have x minus 1, x minus 8. So we have x minus 1 equal to 0. So x equal to 1. X minus 8 equal to 0. So x equal to 8. So what we're going to do now is we have a number line. We're going to plot 1. We're going to plot 8 here. And let's look at x minus 1. Now we're going to look at this root. We're going to use that with the inequality to see what happens. X minus 1, x minus 8 greater than equal to 0. So we're going to use a value from each of the regions. So this region right here shows that x is less than 1. This is 1. X is between 1 and 8, and then this region here is x is greater than 8. So let's look at this region first. Let's use the value 0. 0 minus 1 is going to be minus 1. So we have minus 1 multiplied by minus 8 greater than equal to 0. So 8 is greater than 0. So this is a good region. So let's shade it with a different color. So this is an acceptable region right here. Now let's pick a value from here. So we're going to still use x minus 1, x minus 8 greater than equal to 0. So let's pick a value here. Let's say 4. So we have 4 minus 1, 4 minus 8 greater than equal to 0. We have 3 minus 4 minus 12 is not greater than equal to 0. So this is not a good region. And then let's try 9. So x minus 1, x minus 8 greater than equal to 0. 9 minus 1, 9 minus 8 greater than equal to 0. So we have 8, 1 greater than equal to 0. So 8 is greater than equal to 0. So this is also an acceptable region right here. Now let's see whether we're going to, because this is greater than or equal to, let's plug in 1 and 8 and see what happens. So 1 minus 1, try that. X minus 1, and then x minus 8 greater than equal to 0. So 1 minus 1 is, and then 1 minus 8 greater than equal to 0. 0 minus 7. So 0 is greater than equal to 0. So we have a situation where this is also an acceptable point. An acceptable point, x equal to 1 is acceptable. And then let's try the same for x equal to 8. So we have x minus 1, x minus 8 greater than or equal to 0. 8 minus 1, 8 minus 8 greater than or equal to 0. 7, 0. So 0 is greater than or equal to 0. So we now have x equal to 8 is also acceptable as a point. X equal to 8 is acceptable as a point. So now here's our solution set, right, in a different color. So we have x is less than equal to 1, x is greater than equal to 8. So that's our solution set. Same thing we're going to do here. We have x squared plus 3x minus 10 less than 0. So we start with x squared plus 3x minus 10 equal to 0. We have x plus 5, x minus 2. So x plus 5 equal to 0. So x equal to negative 5. X minus 2 equal to 0. So x equal to 2. Now we're going to plot this on a number line. We have negative 5 and then we have 2. So let's examine our regions. We're going to start with this region here where x is less than negative 5. So let's start with our x plus 5, x minus 2 must be less than 0. So let's use negative 6, negative 6 plus 5, negative 6 minus 2, we say must be less than 0. So let's see if that's true. Negative 1 multiplied by negative 8 less than 0. 8 is not less than 0. So this is not a good region here. Let's use 0. Let's go again. X plus 5, x minus 2 less than 0. So 0 plus 5 is 5. 0 minus 2 is negative 2. And then we have less than 0. So negative 10 is less than 0. So what we have here is, this is a valid region. Now let's try the last region. We have x plus 5, x minus 2 less than 0. We're going to use 3. 3 plus 5 is 8. 3 minus 2 is 1 less than 0. That's false. 8 less than 0, false. Or we can put this to show that it's not true. And so this is not going to be a region. Anything greater than 2 is not a region. And here, if it's less than, it means that the values. So what we're going to do here is we're going to draw a circle here. We're going to draw a circle here. So now our region is going to be minus 5 less than x less than 2. So anything in this region satisfies our solution set. Finally, let's take a look at this example. We're going to make an equal to x squared minus 12x plus 32 equal to 0. So we have x minus 4, x minus 8. So x minus 4 equal to 0, so x equal to 4. X minus 8 equal to 0, so x equal to 8. So we're going to plot our number line. We got 4 here, and we got 8. So we're going to examine the different regions. So x minus 4, x minus 8, greater than or equal to 0. So let's try 5. 5 minus 4, 5 minus 8, greater than or equal to 0. So we have 1 and then minus 3, greater than or equal to 0. So we have negative 3, greater than or equal to 0. That's false. So this region here will not work. Let's put an x here. Now let's try another one. X minus 4, x minus 8, greater than or equal to 0. Actually, that is for this region. We haven't addressed this region yet. So we're going to use 3 for that region. 3 minus 4, 3 minus 8 greater than or equal to 0, negative 1, negative 3 greater than or equal to 0, 3 is greater than or equal to 0, so this region is going to work. Now we're going to try 9. So we have x minus 4, x minus 8 greater than or equal to 0. 9 minus 4 is 5. 9 minus 8 is 1 greater than or equal to 0. 5 is greater than or equal to 0. So therefore, this region is going to work, and we're going to shade that. We're going to shade that. So our solution set is now going to be x less than or equal to 4, x greater than or equal to 8.